This is a short video showing how we repaired the rudder post on a Capri 25 sailboat. This isn't actually the boat we worked on, but one like it. I think the construction is similar between this and a lot of boats, where there's a stainless steel tube that extends out the top of the rudder and goes through a tube that's fiberglassed inside the boat, and that acts as a bearing. There's not really bearings inside of it, so it's just stainless steel acting on fiberglass. And so in time that wears and this gets sloppy. So this shows what it looked like before we did the repair. This is after years of use. You can see how much movement there is in the rudder, and it wiggles both fore and aft and port and starboard. The West System has a very good guide, repair manual that you can find online easily, and I looked to see if they addressed this, and of course they did. And what they recommended was that you wax the outside of the rudder post with 3 coats of automotive wax to act as a release agent, and you mix up some epoxy with 50% colloidal silica and 50% graphite powder to reconstruct the bearing. Then you load that into a syringe. And then that's injected in 3 points around the outside of this, both top and bottom. And they said to make like a 3/4 inch diameter disc. So this shows the holes that you drill and shows where you construct the bearing. And then afterwards, they say you should be able to break the shaft free by grasping the rudder and twisting it. And if it's too tight, then you add some buffing compound to loosen it up again. Well, I didn't really like this concept. I didn't want there to be a risk of actually gluing the rudder into the boat. And then also the access to that tube inside the boat is pretty limited. So here's the post that's glassed in between the footwell and the outside of the hull. And you can see it'd be difficult to climb down inside that lazarette and be able to inject that as they recommend. What I really wanted to do was to machine some bearings that slipped over top and bottom, made out of nylotron, and then oversize the hole in this tube to insert that bearing. But there was just not enough thickness to work with. This is a 2-inch OD fiberglass tube, and the stainless steel shaft on the rudder was about 1 5/8 inches. So it just didn't leave much room to work. So as an alternative, I came up with a concept to make a mold out of 3D printed parts that I felt like I could break away easily and get out after the epoxy was injected. And the way this worked was I had a top and bottom plug, and in each of the top and bottom plugs there were holes that connected from the ends to ports out the side in 3 places. And then that inserted inside of 3 leafs that went on the outside that actually controlled the outside diameter. And there was one of these top and bottom, and then it took a center plug, and that's the green part, to go in the middle to make up the difference dimensionally. When I made this, I made the outside diameter of this to exactly match the outside of the rudder post, thinking that I didn't want it to be too loose, and if it was too tight, I could use a sander and enlarge it a little bit, but I'd have to do the whole process again if it was too loose. And although this looks a bit complicated, it's really not. There's a lot of people that do 3D printing now, and it wouldn't be hard to find someone to draw this up and make it for you. The 3D printers are relatively inexpensive, and there's just a lot of people doing it. So here are the 3D parts being assembled. As you can see, there's quite a few pieces to it. And before I put this together, I sprayed everything with a mold release. I did go ahead and print some grooves in it to install O-rings, thinking that that would help hold it together. And when I slipped it up inside the boat, that would act like a seal to control where the epoxy went. But in reality, it wouldn't slide up inside the boat. It was too tight. And so I ended up leaving the O-rings off and just using a piece of tape. I did put a spot of caulking on each one of those to hold everything tight together and then taped it tight until the caulking cured. So it made kind of a glued together piece. So here it is all assembled. And you can see the ports on the ends that connect with the holes on the side on both ends. I tried different mold releases to see which would work the best. I made up a little sample to do a bench test on it and tried the automotive wax, Vaseline, and this Stoner urethane release. And all three worked. The Vaseline worked the best. I was concerned about using the Vaseline on the outside of the part because as I slid it up inside the boat, I didn't want any of the Vaseline to wipe off onto the surface I was trying to adhere to. So here's all assembled. As I said, I put a spot of caulking between the leaves to hold it all together so it all fit together tight. And there it is inserted into the boat. And these are the two additives that West System recommended. This is a colloidal silica, which is a white, real lightweight powder, and then the graphite powder. And West System has a relatively simple metering system to proportion the epoxy resin. There's a calibrated pump in both the resin and the hardener, and one pump of each, and you get the right ratio. I think it's 5-to-1. And they recommended adding the colloidal silica and the graphite in equal volumes. So you just used a plastic spoon and put in a spoon of each, and kept stirring it in until I got the consistency I want. And with these additives that go with the West Systems, it's amazing how much you can put in. They've got half a dozen different additives you can put in there, depending on what you want to achieve, the colloidal silica being the strongest. And so we'll fast forward through the mixing here a little bit. I just kept adding a little bit at a time until I got it to the thickness that I wanted. I wanted it thick enough that it wouldn't drip out around the edges, but it had to be thin enough to be able to inject through the syringe. And then my practice, I paid attention to how much of the volume I used, and it took about 15 milliliters to fill one of the ends. So I needed a total of 30 milliliters to do both the top and the bottom. I just wanted some idea of how much volume was necessary. So here we're loading the syringe. Now that the syringe is loaded, I injected a little bit in each hole. And I was hoping I'd be able to read on the syringe how much I was putting in, but everything was black, so it was hard to see. I don't know if it was necessary to plug the holes. The stuff was relatively thick, but I just don't want there any chance of it dripping back out and not completely filling the void. I got a little bit too much in this one. As you can see, it started to ooze out around the edges. And I cleaned all that off before before it hardened, just with a rag wiping it off and a little acetone. And I did this top and bottom. I only videotaped one end to show the process. Then after letting it sit overnight, I drove the center plugs out and I reached up through the center of it and used a punch to push out the top one and the bottom one. The top one came out much easier than the bottom one. I'm not sure I know why, but they both came out. You can see relatively little epoxy got on between the plug and the leaves. So here we're removing the leaves. You can see two of them just popped off very easily. The third one came off relatively easily, but not difficult. So it worked sort of as planned, and the mold release did its job. And after we got done, there was a little bit of lip where all the leaves came together in each one of those joints. I wasn't able to get a picture of it. And to take those ridges out, I found a little flapper disc sander that would go down inside and ran it up and down a couple of times just to get the ridges out. But it didn't take much. Because this has graphite in it, it made sort of a mess. It's like pencil lead. So it was necessary to wipe up all the dust and clean it up with acetone. I sanded both the top and the bottom and then inserted the rudder, and you can see it fits quite nicely now. There's the joint's rigid and the rudder moves freely. So I hope this helps. Feel free to copy it.